Hello everyone. Welcome to this tech talk on generating API clients with OpenAPI or Swagger specification. My name is Thyag Ramachandran and I am a member of the technology enablement team here at OSIsoft. In this tech talk, we will learn how to generate and configure client libraries using OAS 2.0 specification and how to use them to interact with REST endpoints. Before we begin, I'd like to go over a few things. For those who are new to this format, this is a tech talk and not a traditional lab or a lecture. The setting is more interactive and informal. You are welcome to follow along with the demos if you wish, but please keep in mind that this presentation material and related content will be made available to you at a later stage. So let us start with the objective of the talk. Why do we need to develop client libraries to interact with REST APIs? Well, delivering APIs which share common behaviors, patterns, and a consistent RESTful interface will greatly ease the work of people who build them and consumers who want to use them. So, when we say ease the work, what does that translate into? Well, it could mean moving from complexity to clarity towards a more integrated solution, maybe fewer lines of code, or even an object oriented design. You could be the developer who is building applications or writing code to access Pi system data through Web API. And if you are a process control engineer or a data scientist in the audience, you could be the consumer who's looking for API clients to integrate with existing or upcoming solutions. So if you fall into either one of the categories, I encourage you to pick up the ideas and information that you learned from this talk and share it with your counterparts in your organization so that it might be useful to them. So now we know the why, let us look at the what and the how. But before that, let's have a quick look at the agenda. First up, we will see how to interact with REST endpoints with specific focus on Pi Web API, and we will see how requests are formed and executed. Then we will look at OpenAPI 2.0 specification and the Swagger IO tools. We will look at the specification syntax also, but briefly. We will see how to generate client libraries using the specification and also how to set up and configure the client libraries to access Pi Web API. Towards the end, we will see features that you can put in your client libraries to make it behave better and have it more enhanced, and also some additional resources that you may want to explore and how to work with the Pi community. REST endpoints are ubiquitous. Pay close attention, and you are probably using them in your everyday life in the form of APIs from Google, Facebook, or for the more hip audience in the crowd, Instagram. So what is the Pi Web API? So it is a RESTful interface to the Pi system. It gives client applications read-write access to their Pi and AF data over hypertext. So REST is a term that you have heard often. So what does it stand for? REST stands for Representational State Transfer. And in the context of Pi Web API, it specifically means that it's stateless, it's resource-oriented, navigable by links, and so on. So why use the Pi Web API in the first case? So it enables cross-platform development of web, desktop, and mobile applications across many different programming languages. This should spark some interest in most of you because it provides tremendous amount of flexibility. The big benefit is that you can interact with the Pi system within the confines of the settings that you are more familiar with in terms of languages, in terms of operating systems, etc. That is the big driver over here. This enables you to easily integrate with the Pi system without a lot of extra effort from your side. So let's look at a quick demo on interacting with Pi Web API. I know I've been talking about Pi Web API, but what does it look like? How the interaction is with the REST endpoints. Some of you might be familiar with this, but I just want to quickly go over this because it'll give us a better understanding of what we are trying to do over here. So with that, let's quickly look at the demo. So this is a self-contained environment. I have a Pi Web API and the Pi system, that is AF and Data Archive, all installed in here. The architecture could look different, but the principles are the same. So as I said, Pi Web API is
PyWeb is a RESTful interface. It's textual. You see the data that's represented. The format's called JSON. That is JavaScript object notation. It's just a way for you to represent data. And you can see it's hypertext, and it's got links, navigable links in there. So if we quickly drill through this, you'd be able to see, hey, if I get to one point, I can keep drilling through. So over here, I got a data servers. Then I'm trying to get the points in a data server. So this is a typical operation that you would do in your Py system. You want to get your Py server, you want to look at the Py tags in there. If you see, as I keep clicking on, the URL at the very top changes, and also this help pages. One good thing about Py Web API is it's got an inbuilt help section, so you don't have to go externally for help. So if I click on the help, you should see the help section. It's got controllers and actions in there, which typically drive what you want. You typically want to use them. So if I go to get points in here, it says, hey, retrieve a list of Py points from a specified data server. And you see some remarks and some URL parameters. So let's have a quick look at this. So one thing when you search for Py points is you want to search by name. So how was it done? So I have this, and there's a URL parameter in here called name filter. So let's do that. Name filter, I want sinusoid tags. Everyone's familiar with that, I hope. So this returns a list of sinusoid tags. And in a default server, you typically would find two of them, which is sinusoid and sinusoid U. But you see a lot of fields returned and a lot of data returned. But if you look at the other parameters, there's something called selected fields, max count, start index, and things like that. Again, I did not want to turn this into a tutorial on Py Web API. I just want to make some of the people who are not very familiar with it understand what's going on in here. So let's do selected fields. I want the name of the item. So here, now I've searched for the sinusoid tags with just the name and sinusoid U. There are other parameters that you can include. Let's say I want BA colon tags over here. And I do max count of 2. You have more. If I want more tags, I'm going to do a max count of 3. So over here, I just want to stop a little bit. So this is how Py Web API looks like. But the Py Web API users think, hey, since it's HTTPS, I need to have a browser to get to Py Web API. In fact, it's quite the contrary. Like, there are many ways to access REST. The web browser is just a tool. There's a browser engine in there and the rendering engine, which basically performs REST requests and displays this data out for you. Another way to do that, so if I were to do this, and let's say I want to use selected fields in here. And let me do, okay, let's just do something. Whoops. Okay, so I got this output. So let's see, because this is REST, let us look at another tool which does the same thing for me. So let's do. Some of you might have heard of this. This is called curl or curl. This is a command line utility which basically can do the same interaction with REST endpoint. So if I do that, so let me get to the URL, copy that. So if you see, I get the same output back. It's just that it's in a console window, and it's not pretty. It's not formatted in a pretty way. But you are able to get the same response. You don't need a web browser. That's what I want to get to. Because some people have the notion that if it's HTTPS, then I need to have a web browser to interact with REST. Another tool would be Postman. Some of you might have heard of it. Again, this is another way for you to do the same query. So if I do the same query in here again, I'm hitting the endpoint using Postman. So it returns the same thing. Here I'm returning the point ID and the point name, for example. Similar query, name and web ID. So web ID is something that we will come across. It's the way you identify resources in Py Web API for people who are not familiar with it. So I can do the same thing in the browser. So why do I need other tools? The browser is actually limited in what it can do. For example, it cannot, if you have a HTTP verb like post or put, you need other additional developer tools other than just the browser. So you need other specialized tools. Hey, if you can use tools, you don't need a browser, so can it be programmed? So that's what people, when you want to integrate something, you want to have programmatic access to it to integrate. So yes, it can be done. Let me quickly show you a little script I have. This is a Python script which does the same thing. So if you see here, I have a Python script. I am using the streams controller. I am using both the end value in here, and I am using the recorded value for the streams controller. So if I were to to access the REST endpoints here, I'm just calling the recorded values. I've commented out the end value. But if you notice that I'm pretty much using the same controller for the end value over here. But, oops. I'm using the same one for the end value, but if I were to change anything in the parameter, it becomes a little difficult. So I have to make sure that I manually put in the changes in here. And also, any changes to the parameter, for example, if I change the selected field, I have to make changes to the URL in a manual fashion. So there are multiple ways to get to it. So this is what I want to quickly show you what's in here. So we saw a quick demo. So what are the takeaways? Controllers are responsible for responding to requests, and action is a method in a controller. So this paradigm should sound familiar to some of you, at least to the developers over here. This is what you would typically have an object and a method, right? Like you have a particular object and an associated method. Most web API methods accept URL parameters. In general, these are like for filtering. URIs can get long and complex. We saw some of them in here. I know I went through them very fast, but you can see that for different controllers and different actions, you can really get long URLs which are difficult to manage by hand or make any changes to it. So, and also using a web browser is an option. There are many other tools and techniques that are available. But if you start writing your own custom application, which gives you the most amount of flexibility, it leads to unstructured and repetitive code. So that's something that you want to avoid, and that's one of the things that hold back people or developers who want to integrate PyWeb API into their application, because when you start looking at it, there are multiple controllers, and it's very difficult to maintain a set of code which works across all the controllers and all the actions. So for this leads to the question, is there a standardized access possible for PyWeb API? So that's what we are going to look at to ease the work, because you don't want to keep changing your code every time or like keep modifying your controller or the URL every time. So with that, we look at what Swagger is and how this ties in to having a structured access to PyWeb API. So OpenAPI specification was formerly known as Swagger specification, is nothing but the API description format document for a REST API. So it's a document that describes a REST API. The API specification can be written in YAML or JSON. We already saw what JSON was. It's a way of representing text. YAML is also a way of representing text. It's yet another markup language, so it's just a markup language to represent text. So Swagger is a set of open source tools built around the OpenAPI specification that help you design, build, and document and consume REST APIs. So this is it seems like something that we want to check out. The popular tools with Swagger are the Swagger Editor, Swagger UI, and the Swagger CodeGen. The code generator can be used to generate client libraries in over 40 languages. So again, you see it gives you a lot of flexibility, and 40 languages, it covers most of the popular languages. In that way, you can work in a confined environment you are most comfortable with, but still be able to access the Pi system data through Web API. And for people who are wondering, hey, what's this? Do I need to get this product or anything like that? The OpenAPI specification was donated to the Linux Foundation in 2015. And also, Swagger is a set of open source tools. So all this is not proprietary. You could go and start using them right up and not worry about any proprietary piece of code that will be included in your application. So let's look at the Swagger website and the OpenAPI specification itself over here very quickly. Okay, so let me close some of this out. So I am going to the Swagger website over here. It's swagger.io. I'm talking about it. So it talks about all the things that we just looked at. What is OpenAPI specification? If you see, it allows you to describe the operational parameters, the endpoints, authentication methods, and other things. Swagger, we talked about these tools. One thing to keep in mind is these Swagger tools are available both online and offline. For now, for this tech talk, I'm going to show you the online tools that are available, but keep in mind that you can always download these tools and use them offline. For example, if you are in a more secure environment and trying to develop, you need not have a connection to the internet. These tools can be offline for you to work with. And what is OpenAPI? It's becoming more and more popular. Some of you might have used it. Some of you might be aware of it. But OpenAPI specification is becoming the de facto standard for having REST, for using with REST access. So as I said, the OpenAPI, the specification itself was donated to the Linux Foundation. In the tech talk, if you notice at the title, there's a very specific 2.0. That is because there's also a 3.0 version that's available. But for the purpose of this tech talk, we will be looking at the 2.0 version. Just to give you a brief flavor of what the specification itself looks like. It says, hey, formerly known as Swagger, and it actually goes over everything in detail. If you see, it's a pretty long document. It says what the parameters are, how are they supposed to be specified in the specification, what are the types, and things like that. It goes over many things. How are they supposed to be described, what the parameters are, what the structure is. It's more like a meta document for your specification or how to build out the specification. Okay, but this is all good. Like we've seen Swagger, it's a set of tools that works on the specification, and this is a document for your specification. But if your REST endpoint of your REST server is pretty simple, you can go over this and build your own specification. It's not very complicated. But anything that gets like PyWeb API, which has multiple controllers and multiple methods, you are going to find it difficult to generate something like this on your own because there's a wide gamut of things that you want to cover. So luckily for you, for our customers, we have the specification made available to you. This is available both publicly and with every specific instance of Web API we install. So on any PyWeb API machine, if you go to the help pages again, remember the help pages are inbuilt. If you go to topics and if you go to global, you should find a section called OpenAPI 2.0 specification. So again, go to the help pages, topics, global, and it's OpenAPI 2.0 specification. Here there's a description of what the OpenAPI 2.0 specification is. As you can see, it's nothing but a specifically formatted document. It's available in two formats. Obviously, we will look at the human readable format over here. One thing I also want to quickly make note of is this specification, it's not necessary that you have to have PyWeb API installed or get access to the specification from a PyWeb API machine. This is also publicly available from our developer technologies page. So if you go to techsupport.osisoft.com and search for documentation for PyWeb API, you should be able to find this page. Again, if I go to topics and if I go to global, I should see a section called OpenAPI 2.0 specification. So let's just open it up just to see what the specification looks like. Again, this is already being made available to you. We do not expect you to go and start writing your own specification. You are welcome to play around with it. All this is available for free, and all the tools are available. But we made this available to you for your own convenience so that you can start working with it in a more meaningful fashion. Remember, we were looking at get points over here before. Let's see how this shows up in the specification. So I'm going to search. I'm going to see. Oh, here you go. So this is part of the specification. As you see, PyWeb API specification is a pretty long file. So let's go back to that. And it says summary, retrieve a list of points in the data server. It should reflect what's in the help pages. It's just that it's written in a specific format. It says what the parameters it takes. For example, web ID, it's type string. Is it a required parameter, true or false? It says, hey, web ID is required, so on and so forth. So you can start with any controller, and you can look at the specification. You should find some of the documentation. Let's look at one other thing. Let's look at the response. So the response, it says items.point, definition for items.point. So let's see what that one looks like. Okay. So it says it's an object, and it's got some properties and some links, hyperlinks to it. The reason why I want to show this to you is it's not to give you a deep dive on the specification, but if you are ever in doubt what the if you are trying to implement a controller and you generate some clients and you want to know what the specification looks like, maybe I'm looking for an integer, it's showing up as string or things like that, it's pretty easy for you to just pick a controller, go search for it in the documentation. This is all, again, publicly available. So let's go back to our presentation in here. So we just saw the demo. So what are the key takeaways from there? So OAS, or OpenAPI specification, is a standard. It's language agnostic. If you saw the specification, there's no mention of a particular language in there. It's not particular to C# or something like that, because it covers RESTful APIs. And it's for you to discover and understand capabilities of a REST service. So just with this documentation, you can see what the controllers are available, what the response types would be, even without having direct access to your REST application. This is, as I said, it's open source. The complete specification can be found on GitHub. And PyWeb API specifications already made available to you in a JSON format. So it's pretty easy to learn and readable. We haven't looked at the code gen. Let's quickly look at the code generator. One of the tools we mentioned, you can generate libraries. So let's quickly look what the code generator looks like. So again, I'm still in the Swagger website. If you see, it's swagger.io. There's a generator out there. The generator actually has two parts. One is the server, and other is the client. Since we already have a server, which is our PyWeb API machine, what we're going to look, we can ignore that for now and look at servers. It's pretty simple. This is an online tool. It's got just 4 endpoints. Again, these are REST endpoints. Again, so let's get the list of languages supported by the client generator. So I'm just going to try it out and say execute. Hey, if you notice, there's our friend curl that shows up again. The reason why it's there is, say, if you want to automate this whole process, you can do this manually. I'm going to show you how to manually do it. But if you want to put it in a form of script and double click on it and run it, you could. This shows you what curl commands that you typically use to automate it. In reality, you wouldn't be generating multiple libraries, maybe a handful of them. But if you want all 40, I would say, hey, maybe use a script. But if you see the languages that it supports, you see C#. Most of the popular languages should be there. There is Golang. So some people might have attended the Golang talk this morning. And if you're wondering, how do I get access to a libraries, there is a Golang library, Golang that is supported, Java, JavaScript supported, PHP, Perl, Ruby, Python. And for the data scientists out there, there's even an R library that can be custom generated. And maybe you want to integrate your data solutions with PyWeb API, there's an R library. There's also TypeScript and so on. But there are about 40 plus languages. Most popular ones are there. So you would want to pick something that you are more comfortable with. We will come back to this website a little later for custom generation. So let's see. So now we've seen what PyWeb API looks like. What are the constraints for developing a custom solution? We quickly saw Swagger, and we saw what the OpenAPI looks like. So how do we tie them all together? So for the next demo, we're going to look at custom library generation. So how do we build a custom library with all the knowledge that we have right now? So let me close this for now. So again, I'm on the GitHub page for Swagger, which talks about the online code generator. So it says one can generate API client or server using the online generator. That's the tool we were seeing. and it actually documents what are the things you want to put in and how it's done. It's a detailed document. If you want, you can go over, but I'm just going to show you how it's done. It's pretty simple if you have used it before or if you see in here. So there are just 4 endpoints for us to play around with. So there's an endpoint which says generate a client library. So let's pick that one. Let's try it out. So we started, I showed you a Python script. I'm going to generate a Python client library because it's one of the more popular client libraries out there. But keep in mind that if you want Golang or Java, it's just a matter of selecting the appropriate client library from the drop-down menu. So over here, I'm going to pick Python. These properties and definitions are available in the documentation. I'm going to just use the defaults for now. So I'm just not going to add a lot of these things in here. So I'm going to just keep it really simple and just use the defaults out here. So I'm just going to do that. And I'm going to, OK. So the two things, even the options, I'm just going to leave them with default. But I'm going to supply with the Swagger URL. So the Swagger URL, it should be the URL that points to your Swagger specification. And for PyWebAPI, the Swagger specification is available at this link. So I'm going to use this particular URL for the Swagger specification. OK, so I put that in. Okay. And I hope that you can see some of the text at least. I know for the people at the back, it might be a little difficult, but it's just, I've just replaced the options in there with the default ones, which is blank, and I've just put in the URL for PyWebAPI. So I say execute in here. OK, so when you do hit the execute, you get a 200 response, HTTP, which is good. And you should see something in the response body with a code and a link. The link, you can directly use the link to download the library or the code. Some of you, when you try it out, you might see a download button over here. Unfortunately, that's not the direct download. That's just to download this response body. So if you download that, you'll just get the JSON. So let's just use the code in here. You can also directly use the link, but I just want to show you how the code's used. So all we did was we went to this endpoint. I used the default option and just mentioned the Swagger URL. So there is an option, downloads a pre-generated file at the very top. So what I'm going to do is I'm going to paste the code in here, and I'm going to say execute. And here you go, you have a download file option. So all we did was put the URL in, point it to the specification, and let the online generator do the work for us. So I'm going to download this file. Let's see, desktop. I'm just going to put it in demo, and let's look at the file. Desktop, demo, over here. So I have a generated zip file in here. So let's extract it to the same location and see. OK. Let's extract that. Any pressing questions so far? Remember, we also have a Q&A session towards the end, so we can go over some of the stuff again. So let's see how it looks like. I'm sorry? OK. No. All right. Not a problem. So if you see, I've extracted the file, and it says Python client. It's got some files in here. I'll go over the file structure with you guys just so that you're familiar with. Again, remember that all this was auto-generated, so you don't typically have to spend too much time digging into these. So again, anytime we see if we see a library or when we get a package, the first file we ignore, ironically, is called the README. But I want to stress over here that the README is the most important file over here, because each language has its own set of requirements, and intricacies and configurations that you need to put in. So for example, if you were to generate a Java client, one of the prerequisites or requirements would be a JRE and a JDK. For .NET, for C#, you need .NET. For Angular, you need other libraries. So this is very, very critical that when you generate your client libraries, you are looking, the first thing that you want to do is go through the README file. Again, my assumption over here are typically what you would do is generate libraries in languages that you want to work with or you are already comfortable with or you want to integrate with your own solution. So in that case, a lot of things would make sense. I'm going to go over some of the things for non-Python users. Some of this might not ring a bell, but please keep in mind that for your own particular language, some of the requirements that show up would make more sense to you. So over here, let's see. So the first thing it says, the Swagger spec that describes PyWeb API, it gives you some version. Again, all this was auto-generated. The effort that was put in by me was just clicking around, but just to know what to put in there and click around. It says requirements, Python 2.7 plus and 3.4 plus. So let's actually check what we have. Oops. So let's say, so I have Python 3.6.6 over here, so that satisfies the version. It also comes in with source control on Git. So if you can directly host this on a GitHub repository, work with it, share it with your teammates or with your counterparts who want to work with the project. It's got source control, inbuilt source control scripts to do source control, but we're not going to go over that. I'm just going to work within my environment, but keep in mind that this is also possible. So it says we can ignore this section because it says source control on Git, but let's come here. So setup tools, it says, hey, install this and says Python setup install user. So there is a setup.py in here. All this does is it has some packages and it checks for some requirements. So let's do that. So I'm going to go back to my README and I am going to copy this. Let's clear this out. So I am going to run the setup.py that is in my README. So it's trying to do something. It's checking for the requirements. It's building out the packages and things like that. Again, the one thing I want to again stress is just understand the concept. The steps are going to be very, very similar to your client library, but it wouldn't be the exact same steps. Here I'm running a setup.py script. In .NET, you'd be asked maybe to run a batch script or a PowerShell script. So it's just going to vary with the environment and the language, but the steps are the same. You just follow the README. And if you're not hosting on Git, it makes it even more simpler because everything is going to be in your localized environment. OK. So it seems that it's generated. It's actually built the libraries for us. It's got a Swagger client and a test client. So now that we have this, let's go over the directory structure. I told you that I'll go over the directory structure just to see what comes up when you auto-generate the client. So first we saw the README. Please don't ignore the README. I know that that's our favorite as programmers, just to skip over that, just to show who's the boss, but please go through the README. There's some Git scripts in here. So it actually comes in with two things. One is it's got the docs, which goes over the documentation. This .md, when you put it on GitHub, you'd be able to see it's nicely formatted. Every controller and every action is documented. The other is the Swagger client. The client has two things. One is the API and the models. So if you remember, in our PyWeb API, you had controllers, you had actions, and you had some return types which had some properties. So typically, the clients correspond to controllers. The API client corresponds to controller and action, and the models are like the responses and things like that. Other than that, there are some additional files in here. And also, for people who want to do some testing, there's also an inbuilt test suite that comes as a big bonus. Hey, you don't even have to build your test scripts. All this comes in as a big bonus. But again, using that is up to you. It's not necessary. It just comes as part of the library. I want to warn you over here a little bit. Not all languages come with a test framework. I think most popular languages do, C# does, Java does, but if you're using Scala or TypeScript, I'm not sure. I think some of them don't have a test framework that comes along, but it should be pretty easy for you to integrate that. If we look at the files themselves, you see they're neatly formatted with all the comments in there, all the methods. Again, for non-Python users, don't be scared. It's going to look familiar in your own language. It's got configuration, it's got REST, it's got an init, and so on. So all this, if you see, was generated without us typing a single line of code. But life's not so easy. You would have to do some amount of coding. But we've got all the template and the base structure already built in for us. So let's go back to the README now that we have done that. And that's it, pretty much. So it says README stops here. It says the getting started section. If you get to the getting started section, then you have to roll up your sleeves and now start typing away code. And as you see, we haven't done any major part. All the files and the configuration and things like that were all auto-generated. And these came from the Swagger specification that was automatically provided to you from PyWeb API. So let's do something. So let's just go back to the README one more time. Over here, there is an example on how to use that. You can follow along with the example. But here, it uses the analysis API. For people who may or may not be familiar, this is AF analysis. The reason why it's showing up in the example is there's nothing fancy or special about analysis API. It's just that it's alphabetically that shows up first in the list. So don't be scared. So I'm going to use a simpler API, maybe the home controller. I think everyone should be. So if you go back to PyWeb API, the very basic controller is the home controller. Let's try to get to that. And typically, when you want to test PyWeb API, I would say, hey, test with the home controller, because if that works, if that doesn't work, then there's high probability nothing else works. So let's close this one out. Let's go back in here. Don't save. Let's go back in here. I'm just going to create a new file. I'm going to say my file. Again, pardon my naming convention. I just want to show the functionality in here. So when we do that, and again, I'm going to cheat a little bit. Again, a little bit. You see all these imports in here. I'm just a little lazy to type it out during a live session, so I am going to just copy paste all of them and some of the code in there. So do that. In fact, let me go back to my presentation, and I have some snippet. I'm just going to copy paste some of the code from here. Okay, so what have we done in this file? So again, if you go back to the README, if you go to the example, there are some import functions. Those are like typically using statements in C# or like getting some libraries, or like hash includes in like C++ or C languages. And there's an instance. This is something that will be repeated over and over again. I just want you to be a little familiar. We said, if you remember at the beginning, REST calls or PyWeb API are stateless. So what does it mean? So between calls, a stateless operation doesn't have any knowledgeable information on what the client previously did. So every call is treated on its own merit. So you would have to make sure that the instance is used every time. Again, you could use that, but once you lose that, once you make a call, you have to, again, instantiate things. It uses an instance, and there's a client configuration. Over here, I'm doing the exact same thing over here. I use the imports. I do the client config. I've just split it up in here. The config is separate. And for people who are just curious what this config does is, again, this is a class configuration. I am just instantiating the class. I'm setting the host and SSL, and I'm creating a client, which I'm just splitting out the steps. And I am trying out the home API. So let's see how it works. Okay, let's see. First, I'm going to change. This is a quirk of the IDE, so I'm going to change the terminal to debug in here. And let's see. Okay, so we got some response. That is good. So it's printed out some links. Hope you can see that. So what did we do over here? With the client, with just a few lines of code, we were able to encapsulate a lot of things that would have required a lot more to type out. So for example, I've used an instance, so I've used Swagger client home API. So remember, the API clients typically correspond to controllers, and I've got the response. So let us try to do something a little bit more, I would say, different maybe. So let's do the point API, which is maybe you want to search for PyPoint by path. So I do the same thing, just to show you how easy it is compared to. So you can treat them as objects and methods now. For people who are not familiar with REST or the principles of REST or things like that, all this is being abstracted and encapsulated. So you can treat this as if it's a class, a library, and you can create objects. You can call the methods on the objects directly without having to bother about what goes on internally. All that's taken care of by the library. So let me create another instance. So do Swagger client. And again, I want to stress that it's good to use a friendly IDE with IntelliSense because the whole objective is to make our lives easy. I know there are some hardcore programmers who would say Nano or like Emacs and stuff like that. If you're familiar with that, great, but don't make your life complicated. Use a friendly IDE which helps you to autofill and things like that because that helps you save time. So the Swagger client, I do point API. So let's save this. And I do. I will go over them. So again, the question was, what are some of the clients? The one that I'm using right now, if you see at the top, it's called Visual Studio Code. It's a lightweight client. It's if you've used Atom browser before, it's very similar. It's built on the same principles. Visual Studio is one of them that you can use. Again, Eclipse is another one. It's just that it needs to have good IntelliSense and maybe syntax highlighting and like things like that you would expect in a good IDE. The reason I specifically mentioned this was sometimes I've seen people struggle because they don't get autocomplete and you have to type out some of the stuff. Again, if you are a great programmer and if you're very comfortable with it, go ahead with it. But my suggestion would be to use something. Again, the whole premise of starting this is making your life easier with like tools. So let's just stick with that. So again, as you see, as we were talking, this already came up with some auto suggestions. So it says API client. So I do API client is equal to, I think I called it client. Okay. So I do that, and I'm going to use the same pattern in here. API response equals API. So if you see automatically, without me really knowing PyWeb API inside out, I'm looking for the point API, and it shows me all the controllers and methods as all the actions in there as methods. So if you see there's a point get, there's a point get by path and things like that. This is all automatic. So if you are someone who's sort of familiar with Web API or like want to use it or integrate with your product very quickly, this reduces a lot of work on your end to pick out URLs, like pick out the methods, pick out actions, because all this is auto-generated and it's very easy for you to see what's in there and how to invoke them. Just like you would use an object and a method associated with it, it's just calling the method associated with this instance. So let's do get by path. And if you see over here, it says a path and some other ** KW args. We'll go into that a little bit more in detail. But if you see, it says get a point by path. It's got some documentation for you in here. Let's do this first, and let's see what can be done. So I'm going to say path. So let's stick with our friend sinusoid. This is the machine that we are on, if you see at the top. So, and it's local instance to sinusoid, and let's see. Okay, first let me just print the response. just to see before we do anything fancy with that. So for here, I want to get a point by path. I'm not bothered about the URLs. I'm not bothered about many other things. I'm just treating that as an object and an associated method over here. So I have this. Let me comment out the first print statement in here. And let's see if this works. OK, let me expand this. So if you see, it's a little truncated on the window, but if you see, we got the same response. So if I were to go to the PyWeb API using the browser or some curl tool or Postman, I would get a similar response to this one. Let me just read on this again. OK, it's just getting a little. But you see, all this is already inbuilt in here. For you don't have to spend too much effort trying to get there. All we did was use the particular appropriate controller that was auto-generated, and then you call the particular method. We could go on. I could go on typing on and showing you, but let me show you a client that I have built out just to show as an example. Like, if you are the developer or if you are the user, and if you want to have a end product, how it would typically look like. So let me close this out. Let's go back. So we saw the custom library generation. I just want to go over some very quick points. So just to reiterate, the client libraries can be generated in multiple languages, each requiring their own customization. So please read me. OK. When properly defined, a consumer can understand and interact with remote service with minimal amount of implementation logic. You don't have to be very familiar with, as I said, REST or internal workings of PyWeb API to get this logic implemented for a point controller. It was pretty simple, pretty straightforward. It's just a matter of calling a function. You typically want to build your own functions on top of the library. We haven't done anything extra on top of the library. We've just called the library functions. But you typically want to do that to suit your business needs, because you, in a typical scenario, you would want to integrate this or like use this application to feed something else, or use this for data science or further analysis, or like anything that you want to do with your PyData. Finally, user-friendly IDE. I know I keep repeating myself over and over again, but our team interacts with a lot of customers and third-party developers outside OSIsoft. And these are some of the very common pitfalls that can be easily avoided without any effort at all from your side. So let's look at extending those features. As I said, I am going to show you a client that you would typically want to see, or what it would look like. So I am going to start code again. And we'll go over some of the features in a little bit more detail. I know I quickly went over the example, but here. So over here, it's the same client, if you see. I have these files in there that's auto-generated. You see the API, you see the models. And in here, I have something called simple access. All it does is it calls the home controller. Then it creates the instance of a point API. It gets sinusoid. It gets the current value and recorded values. So if you see, recorded values is a call that you would typically use because that's the data extraction call. For the most part, that's the call that you want to get to at the final place. So you get the PyPoint, you get the web IDs, but usually the end goal is to get the values out of the Py system. So that's the call that you would see. And if you see, I've used different. So this uses the point API, but I'm using the stream API to get the current value. And I'm printing out some statements. So let's just first run it just to see how it works and what the output is. Okay. Okay, generated some output. So over here, I got the home controller. I got the name and the web ID of the PyPoint. I got the current value, and I got some recorded values in here. So just so that all this doesn't look like magic, and also I want to go into this a little bit more in detail. If you feel that it's too much information, don't be afraid. As a developer or as an integrator, you don't even need too much of this. But as a developer, this is all you need. But just to give you a little bit flavor into what actually happens in the backend, so let's go to something. Let's go to the stream API, and let's go to the stream get value. Remember, this was already in there in the library. We just called it. So let's just go and see what the actual library looks like. Let me minimize this. Again, not to scare you, but this method, def stream get value, is something that got auto-generated with all the comments in there. Remember, we did not put anything in there. It explains to you what it does. It might look different in a different language. So, for example, public static void or something like that in C#. But the principles are the same. So it has self, which is because it's part of a class. That's the Python convention. It has a web ID. The first parameter that appears is the required parameter. So you don't have to go in here. It says private web, even though in the comment says required. But if it just says the first parameter that appears are the parameter that are specified by name are the required parameters in here. So we passed in the web ID for the stream get value. If we go back to, okay, let me open that to the side. So if you see stream get value, we passed in the web ID. And you see kwargs, ** kwargs. Again, nothing to scare you. It's just keyword arguments over there. That's the way you pass that in Python. So there are multiple keyword arguments. And these keyword arguments correspond to the URL parameters that you see in the documentation. So if I go to the end value documentation, you can see that you have the selected fields over here because end value doesn't have too many, but these correspond to the keyword arguments there. What I'm trying to tell you over here is the parallels between what you find in the documentation, what you'd find in your auto-generated library. So we do that, and there's a return, which is a timed value. Again, this is just a type of object that is returned. We can go over that. There's complete documentation, and if you see that it's making a bunch of calls. There are async calls that you can make. There are synchronous calls. And if you keep going down the rabbit hole, you would see more and more of how the library is built out. So it calls in a whole bunch of methods, and it says, hey, API client call API. So let's go to definition. So it goes to calling the API. Oops, let me go back up a little bit. So call API. Okay, it goes to the API client file, and then you have a method which is internally called. And this actually, if you see, it creates the header for the request, the body for the request, the response type, so on and so forth. Let's see. I'll just close this out so that you get more space. You can keep drilling down. I just want to show you the complexity that is involved in the library, but you can, all this is abstracted from the user or like once you generate the library. If you were to do your own custom code, you would typically want to implement methods similar to these because you want to have an overall class, then you would have, you would derive from the class, then you would have a method to call, make REST calls and things like that. All this is abstracted from the end user. So let's close this. And let's go back to our friend recorded values call. Again, so if you see recorded values, you see over here, I pass multiple parameters. And if I go to the definition again, same way. So there's web ID, but keyword arguments, but there are multiple keyword arguments in the recorded value call. So if I say open to the side, there are multiple arguments that I pass. The max count, the start time, and again, recorded values, you would typically expect more parameters that you need the start time, end time, maybe the number of values that you want to get to. This is mapped on to the stream get recorded. And if you see, this is part of the stream API in here. And all the APIs reside in the Swagger client API. There's the API, there's models. Models are typically return types, the APIs. So as you can see, a lot of things is being done for you in the background. But what you typically would do is just access this way. Directly call the clients, again, instance, response, and you can, over here for this demonstration, I'm printing out the responses, but maybe this is just start of the pipeline for you. Maybe these responses get fed into some other process or application, or maybe a graphing tool, and then you start from there. So we just saw client direct application, so let's just see how we can extend access to it. So this is all out of the box. So in a scenario where you are, say, for example, you're the project manager or you're the developer or maybe you're the end consumer who wants to say, you go to your manager and say, I want these features. Now that I know I can generate client libraries in any language, I want these features in there. So what do you typically do? Over here, just to show you as an example, I have created a helper class, which basically calls in, again, this is a class in Python. It might look slightly different for you in your own language. But this encapsulates all the settings. I have the home page in here. I have the list of data servers and list of pipelines and things like that. So if I go to extending the access, so I have a list of methods for which the end user would see, hey, I want to get a list of Pi servers. I think I have some uncommented section in here. Let's just comment that out. So I want to see a list of Pi servers and their web IDs. So again, this does not directly use the library, but I've built a helper class that is actually a wrapper for the library. Remember, the library is just like a base template. You buy a house, you want to decorate it or like customize it to your own use. So treat the template, treat the client library that is auto-generated as the base template over here. So let's just see. Let's just run it and see what it does. Okay. Oops, I think I had the wrong method up there. Oh, this is find pipelines in the server. I'm finding all the pipelines that are to a particular web ID. So for the user, when you want to expose a method, even though there are many things in the library, maybe you just want to expose a search method or to your application just a search one. So you can hard code the web ID of the server, and you can just say, hey, this is the parameter that I get from the user. So if I change this to maybe CD, some other set of tags for the user, and if I were to run this, remember for the user or the applications is the only exposed method, so they don't have access to the entire library because you have encapsulated that. And if I were to do that, let's see. So I got all the pipelines that starts with the name CD, so CDT, CDEP, and things like that. So this is one way that you can extend your library. Just have a wrapper around it and only expose the methods that are really required. Remember, the library is pretty extensive. It has, for example, if you don't want your users to access analyses or event frames, you can just abstract it out. So if you go back to my helper class in here, let me minimize this. I've just exposed some of the methods. Again, these methods use the library internally, but what's exposed to the user is just some of the methods. And the way you would control how the methods are accessed is supplying the keyword arguments. You can suppress some of the arguments. You can expose some of the arguments so that your application or the user has access or like works with only a particular set of arguments in here. So again, if you see all these, for example, my summaries, I'm using the API instance. I'm using the stream API, which we used. But I am exposing the summary type and the calculation basis, and internally I am passing some parameters. So if I were to run the summaries call over here, let's see how it looks like. Let's do that. So I want the summary of CDEP 158. This is one of the tags. So let's just wait for it to execute. Okay, I've already commented out the ones before, but you can see, let me just comment this out so that the output's a little bit more clear. So somebody approaches you, so you have a data science project or like some other project that involves calculation. So what do? First step would be, or like for anything with Web API, is typically generate the client library so that you can work with REST access with something that you're familiar with and it can integrate. The next step would be going beyond just generating the client library. You would typically want to build out a wrapper around the library. Again, this is not a required step. You can just hand out the library or like give it to your development team as such. But a nicer way to do it is to have another layer of abstraction to it so that everything in the library is not exposed and your application just talks to only certain features and not all the things are available for all the users. So for example, I got the summary calculation in here for CD EP 158. If you see the amount of code that is actually required by me, either in my application, so I'm just declaring the web ID, I'm saying what the calculation basis is, event weighted, the other options time. I say, so what are the summaries that I want? Then I just make a call and I print them out. And if you use a summary call, again, it's just few lines of calls. I create the API instance, I call the method, get summary, and I just return the response. So what would have been a complex call if you were not implementing the library, what would have been a complex call of many lines, first declaring all this, then making a REST call, then correcting the URL parameters, making sure that all the parameters are correct, performing checks, which is again very important. Like when you typically write that, you manually would put in checks, hey, is this parameter correct or not? All this is taken care of by the library. So this is one way of extending the library. The other way of extending the library is having more functionality that is not part of the library. So let me close this one out. And just so that we really haven't seen anything with elements, just to show you, it's the same as elements. We've been talking about pipelines all the while, just so that you don't think it's only for pipelines. I'm just going to run this. It's very simple. I am giving the path, and I am printing the web ID and the children of that particular element. Okay. So this is the path of the element. It's the web ID of the element. Oh, this has no children. But say, for example, you're building an AF application or AF analysis, or you're going through the hierarchy, you could still use the library to do exactly the same. So one other thing, so with that, so this is all out of the box, right? You use the library and things like that. There are a few other things that I want you to be aware of when using Web API in general and the client libraries. One is these libraries are extremely powerful. So when you make recorded calls, like you could like pass in parameters, becomes very simple and trivial to retrieve a lot of value. But if you see in most of my calls, at least earlier, there's something called selected fields that I use in Web API. This is something that you also want to put in. So for example, if I go to my helper class, so every one of them has selected fields in there. I typically use them. That's what I recommend, because one, that reduces the network traffic, because you're only performing, you're filtering the data not on the client side, but on the server side, so that the amount of processing that you do on the client is not very high. And also, the network traffic is reduced because your datagram sizes are small. Because if you see a typical response from Web API involves many fields, you want to make sure that you restrict some of the fields. The other big part is using these client libraries to incorporate WebID 2.0, because some of you may be aware, some of you might not be aware. WebID 2.0 is the different way to specify WebID. There's a 1.0 version, there's a 2.0 version. The big thing about 2.0 version is these can be client-side generated. So typical call to Web API would be, the first call would be, hey, go there, get the element, get the web ID of the element, and then with the web ID of the element or attribute or any other resource, perform these operations. If you see, there are two calls you're essentially making, even though you just want like one call being made. And these calls are going to the server, so this involves hitting the server responding. And in your scenario, if in a company, if you have multiple users requesting a lot of data or a lot of these requests, it could lead to traffic congestion and things like that. So one thing that you can do is, from the client side, generate web IDs on your own. So here I have a typical example on how it's done. It's pretty simple. It's not very complicated. I've just put it as part of the helper class. I will show you the documentation where all this is available. But in your library or in your custom solution, what I would typically like to see is have web IDs generated automatically instead of hitting the server every time. So here, this is just part of the specification. Again, this is all client-side generated, so you don't have to do that. Just to check how it works, I already have the web ID in here for this path. Let's comment this one. And I am generating the web ID automatically. So I think the method's called tag path web ID gen. Okay. Okay, I think those were the previous, but oops, I think I modified them. BA conc one. Oops, I'm printing out the wrong web ID, just so that. So CD EP 158, let's see if the web IDs match. So the reason why I'm showing you this can easily be put in any client library. There is no trick or anything. It's not custom generated as part of the client library, but this is something that you want to put in your client library because it reduces the number of calls, not the amount of data received in each call, but just the number of calls by about 50%, because the first call you make is for the web ID. So if you can somehow get rid of it, over here, if you see, I already have the web ID, but this is client-side generated so that it becomes very simple to deal with. The final part is, hey, this is all good. Like I'm printing out some statements and things like that. As I said, this process of using the client library to get data should be the first part of the pipeline in which your application is using PyData. So typically, you're channeling that data into another application, either for plotting purposes or from data analysis purposes or from data science purposes. So if you're using it for data science purposes and you want to integrate with the application, you typically want to use a language which renders or which enables data science. So for example, Python over here. Most of you would have heard of pandas or data frames or used them. So picking the right language helps you to do that. So over here, I'm not going to go over an extremely complex example in here, but just to put the data in a data frame and to show how it looks like. It's very simple. So if you're just a data scientist and you just want to get the data in data frame so that after that you can take the data and run with it and like do some magic on it. The only thing that you typically want is either just part of the client library or from your development team or just yourself. Now you know how easy it is to generate a client library, is to integrate that with part of. So over here, I'm using the pandas import statement. If you notice, it's popular with Python. So for example, if you're using R, it would look different. If you're using some other library, it could be different. So over here, I am, again, the only call that I'm really interested in is recorded values, which I have done. And this recorded values corresponds to my recorded values call, which is from the library. So this is a library, and I'm using the stream get recorded over here. Pretty simple. All the parameters are in here, and the only thing I'm doing is instead of just printing it out, I'm putting it into a data frame. I am printing out the data frame just to show you, but again, there are like some aggregates that you can run. You can run some plots with your data frame and so on and so forth. So this could be the starting point of your development or work with PyData. And previously, you would have to write your own custom solutions, AF-SDK, PySDK, even PyWeb API. But the number of lines and the other thing is the task of maintaining it. So what if there's some change to PyWeb API? What if a controller changes? What if an action changes? What if the response changes? Well, you know how to get the specification. If there's a newer version of PyWeb API that's coming out, all you need to do is, hey, get the newer specification and generate the client library. Typically, 99.9% of the cases that should not be required. But if that is required, you don't have to go through the hassle of going through your entire code base to make some changes. All this can be automated. So just to show you, finally, just to put in a data frame and show you how the data frame looks like, just going to go over some of this stuff. Okay. Oops. So I have the data frame here. It's in a nice table format. You don't have to print it out every time or like supply it. So this is a data frame. Even though I'm printing it out, you could just use this and you can generate large data frames, start working with the application. So as a data scientist or a process control engineer, I'm not really interested in the internal workings of Web API or how to make REST calls or even what's stateless, what's resource oriented. I want to get started with my job and start doing meaningful work pretty soon. And this will enable you to get started with Web API with minimal amount of implementation logic. You don't have to go at things in too much detail. So with that, let's look at some of the things that we discussed. I think we talked about selected fields parameter, reduce the work on the client, make the server do all the work. WebID 2.0, we haven't really discussed, but you can append multiple WebIDs. So for example, if you want to get the current value of 500 PyPoints, so you can typically put them in a call and append all the WebIDs, but that would lead to a very long URL, and also that would lead to some resource limitation on how much your browser can handle or how much the application can handle. But if you can generate them on the client side, you can get significant reduction if you use particular types like path only or ID only instead of full web IDs. So that can be done. So implement that. If you notice, we did not pay too much attention to the authentication from the client. That was a little bit on purpose because it would depend on what scenarios you would use. There's basic authentication, there's Kerberos, and there's anonymous and things like that. There's also API keys. The way you would work with authentication is, one, you can directly put it in part of the Swagger specification. If you remember the specification details that I showed, it can go in part of the security definitions. Or what you could do is you could go and modify that in the client. The reason why it did not go into that in detail is it depends on platform to platform, and it's very language specific in terms of authentication, but that's something that you want to pay attention to when you start developing. Finally, one other thing that I want you to talk, the extending library for data science we talked about. Hey, if you can get the R library, then you're like already halfway there. You're already set. Other is Python, Pandas data frames, but if there's other languages that make use of nicer features that can be integrated with the application, do that. One other final thing is some of you might be familiar with the channels controller or the stream updates controller. That's to get live data. Currently, that is not being implemented as part of the Swagger specification because that involves WebSockets and there are certain things that need to be put in a generalized specification. But just to show you how that would look like, so let's just do this. So I have a simple program in here. Let me open it and show it to you. But as part of extension, you would typically want to do that too. So, oops, let me close this out. So this is simply a simple WebSocket application. If you see, it uses socket address. This is to subscribe to channels, that is live updates. So all we've seen is getting current values. You could poll for current values, but typically in your application, if you are streaming, for example, you want to implement something for channels or stream updates. So this is, oops, just to show you. Again, this can be part of the library or not, but it's up to you what you want to typically do. So let's go back to our library, and let's go to extending access. And over here, instead of data frames, what I want to show you is how you can, it's very simple. I'm just going to post a few values in here to my controller. I'm just going to update values just to show you. So let's change the date to the 10th. Oops, not the 20th, the 10th in here. So yes, I am writing values now. The reason why is I want to see, as I said, if I get live data. So if I write to the archive, I should see some live data, hopefully. So let's just run this call. Again, the response should not include too many things because it's just a post request to the server. Oops. Let's see. Okay, you see, I wrote two values in here, 98.7 with a timestamp and 65.4 with today's timestamp in here. This is not implemented as part of the Swagger specification, but this is something that you also want to implement in here as an additional like convenience, or like if you want to use streaming. But the rest of the controllers and things are already covered in Swagger. So let's go back in here. So getting data in real time, that's something you want to do for extending the features, web selected fields, and data science. So we've looked at a bunch of stuff in here. So what have we got right now? So all of you know how to generate client libraries. So if you notice, that's like from Mattel, He-Man. So you have the power now to do whatever you want. You could be the data scientist, you could be the developer, but keep in mind that you are the master of your own language, right? There are things that you can put in, or maybe you have developed, that can be easily integrated. Once you know, hey, this is a language that I'm familiar with, I can work with. Once you get the client library in there, then you can run with it. There is nothing that can stop you. There's nothing in the way of, hey, this is the things that you can or cannot include and how you want to integrate with the application. I've just shown you a very simple example on how to extend, but again, I just want to repeat that this is like a base template. This is like your home. You buy that, and then you can just extend it or decorate it or like do whatever you want with that. So again, before we conclude, some additional resources that I want to point to. These are hyperlinks. Once these slides are available to you, you can access these hyperlinks. This is a very good post by a colleague of mine on using WebID 2.0. All this is documented, so don't worry. I know I quickly went over that, but there's detailed description on how to generate WebIDs. Feedback and enhancements. If you work with a Swagger specification, and maybe there are certain things I talked about extending, but maybe you like that part of the specification, or you want the specification tweaked a little bit, or like you want it in a particular fashion, then you can use that link to provide us feedback or like enhancement requests for PyWeb API Swagger specification. We have our product managers and our development team listening to it, so we'd be glad to help you out if that's a popular feature that is requested by many of you. The third thing is there's the Py Developer Club community on PySquare. So share your ideas. Maybe you've developed something cool, like you want to share with the Py community, or maybe a charting application with the client libraries. So we'd like to hear that from you, what you've done, so that it's beneficial for the community at large, and also we can help you out with like, hey, maybe we can point you to the right direction. There's also contributing to the OSIsoft open source projects. If you develop something, you can look at the guidelines on what it can be done. Finally, there's a lot of talk about Web API, but I know I went over it very quickly at the beginning. But if you're really interested in learning more about Web API, on day 3, that is tomorrow, there's a developer lab here at Park 55 at the Hearst Room. So go check it out. With that, we come to the tail end of the talk. My name, again, is Thyag Ramachandran, member of the Technology Enablement team. That's my email address if you want to reach me, or if you want to give some critical feedback on this talk. So if, again, we have a few more minutes left, so if you have any questions, please, I have a microphone here with me. Please use the microphone, state your name and the company, and please remember to complete the survey. And with that, I thank everyone who attended the talk and hope you got something interesting out of it. Thank you.